here. So it says find the distance from A to B. So that's the square root of the change in x squared plus the change in y squared. The change in x goes from 2 to 6, so that's 4 squared. 4 to minus 2 is negative 6 squared, and we add them and take the square root, so that's 16 plus 36 square root of 52. And 52 has a 4 in it, so that could be 2 square roots of 13. 4 times 13 is 52. But you don't have to do that. You can leave it there. Find the equation of line through A and B. So the slope would be change in y, which we just decided was negative 6, over the change in x, which we decided was 4, which is negative 3 halves. So if you like y equals mx plus b, it's y equals negative 3x over 2x plus something. If I put 2 in for the x, that would cancel out 2, and I get negative 3 plus something would have to equal 4. If I'm putting 2 in, I'm supposed to get 4. So negative 3 plus 7 would make 4. If I did it with the change in y times x minus change in x times y equals a constant, that would be negative 6x minus 4y equals, and if I put in the 2, I get negative 12, and 4, I get negative 16. That's negative 28. I can multiply everything by a negative and make it look like that. Or if you like the point slope form, it's y minus 4 equals the slope, negative 3 over 2 times x minus 2. Or you could do it with the 6 and the negative 2 also. Find the equation of the line through the point, this point parallel to the original line. So I'll just take the original one. Y equals negative 3 over 2x. To be parallel, to be perpendicular, oops, I thought it said parallel. It says perpendicular. Y equals, it has to be the negative reciprocal. So it's going to not be negative 3 over 2, but the negative of it, so that'd be positive. Reciprocal would be 2 over 3x going through 2, 0. So if I put in 2, I get 4/3, but I'm supposed to end up with 0, so I'd have to have a minus 4/3 to end up with 0. Write the equation of the circle in general form, so that's x minus the x-coordinate of the center plus y minus the y-coordinate of the center, minus 2, so that'd be plus 2, equals the radius squared, so that'd be 25. And that's it. Oh, that's the standard form, and so the general form, I'd have to multiply this out. So this is going to be x squared minus 3x minus 3x plus 9 plus y squared plus 2y plus 2y plus 4 equals 25. And so I get x squared plus y squared. We put the squareds first. Minus 6x's plus 4y's. And 9 and 4 is 13. Minus the 25 would be minus 12 equals 0. Find the center and radius of this one. So I have x squared plus 6x y squared minus 7y equals 10. So I do x minus half of that plus y squared, y minus half of that equals r squared. Now, if I multiply this out, I get x squared, and doing both of them, it's going to be minus 6x, and minus 3 times minus 3 is plus 9. So that multiplied out is this, like I was multiplying out up here. I had it right up there. This one's going to be a little different. It's going to be y squared minus 7y plus 49 fourths. When we take minus 7 halves times minus 7 halves is plus 49 fourths equals r squared. Now, the x squared, y squared, and all this is equal to 10. So this and this, well, this is plus 6. So that's plus here. That's minus. So this is plus there. It was plus 6x. Half of plus is plus. Okay, so that plus y squared minus 7y, that's all 10. Plus the 9 we still have, plus the 49 fourths is r squared. So that's 19, and that's 10, 12 and a quarter. 19 plus 12 and a quarter is 31 and 1/4 is r squared. So in find the center is, so it says find the center and the radius for this. So the center's at -3, half of that, and half of that, positive 7 halves. And the radius is the square root of 31 and 1/4. Okay. Determine the domain. Well, the thing that could go wrong here is taking square roots of negatives. So 2 minus 8x can't be negative. It can be greater than 0 or equal to 0, but it can't be negative. So what can it be? Let's subtract 2 from both sides, and we get -8x has to be greater than or equal to -2. Divide both sides by -8. And if I divide by a negative, I got to flip the sign, so I get x is less than or equal to 1/4. So it would be, or from -infinity up to 1/4. 1/4 makes this be 0. 1/4 of 8 is 2. 2 minus 2 is 0. And I need to use negative numbers to turn that to be positive. Page 2. Graph this. Piecewise-defined function. So it's saying y is equal to 3 minus x. If I put in, I didn't do a very good job of that line. If x was 0, we would be at 3. If x is 1, we'd be 3 minus 1, we'd be at 2. And 2 would be 1, and so this line's going like this, but I'm only supposed to draw it for x less than -1. So none of this starts not at -1 in the x, but for less than it. So it goes like that. The other piece is y equals x plus 2. So when x is 0, we're at 2. When x is 1, we're at 3. And so it's going like this. slope of 1, y-intercept 2. We're supposed to do this from minus 1, including the minus 1. Minus 1 in the x is right there, to up till 4. 1, 2, 3, 4. So that would take me clear to there. And it was including on that end. Intercepts. The only intercept we have is 0, 2. What happens at minus 5? Minus 1, 2, 3, 4, 5. We have to use the top equation. 3 minus a minus 5 is 8. And what happens at 2? 2, we're in this equation. 2 plus 2 is 4. 1, 2, we're at 1, 2, 3, 4. Okay? All right. We're supposed to find g minus k. G is x plus 1 minus k is x plus 5. We subtract those, we get x minus x, which is 0, and 1 minus 5 is negative 4. We're supposed to find, and this is a filled in dot, so we're supposed to multiply f times g. So we got x squared minus 2x for f. G is x plus 1. So x squared times x is x to the third. X squared times 1 is x squared. Minus 2x times x is minus 2x squared. Minus 2x times 1 is minus 2x. Those are like terms, so I get x to the third minus x squared minus 2x. We're supposed to put h of x into f. H of x is this. So f is, so we got f of h of x, and that's the square root of 3x minus 2. So we got to put that in place of the x's in f. So we're going to have to do, x is going to be replaced by the square root of 3x minus 2, and then we're going to square that. Then we got to go minus 2, and then in place of that x, we also have to put the square root of 3x minus 2. Now that squared is 3x minus 2, because the square gets rid of the square root, but we can't do anything with this. So there's our answer. So D says we have to be able to put stuff into H, and what we get out of H, we have to put into K. Well, K can accept anything, so all we have to be concerned about is being able to put it into H for the domain, and so the square root, we have to make sure that 3x minus 2 is greater than 0 or equal to 0 to be able to put it into H. It has to be positive under the square root or 0. So if I subtract 2 and divide by 3, I get x has to be greater than or equal to 2/3. Then divide by negative, so that would be the domain. Or from 2/3, including 2/3, to infinity. Determine H inverse. So if H equals the square root of H of x equals the square root of 3x minus 2, make that a y, equals square root of 3x minus 2. Switch the y's and x's, so x equals the square root of 3y minus 2. Solve for y, so get rid of the square root by squaring both sides. So add 2 to both sides. And divide by 3 and write the inverse. So h inverse of x is x squared plus 2 over 3. Whoop, was off the page screen again. So I got this, squared both sides, subtract 2, or add 2 to both sides, then divide by 3, and write the inverse. And F, we're supposed to determine the domain and range of H inverse. Okay, let's go back to what H was. H was the square root function, which is a sideways parabola, but only the top half. It was stretched by 3 and moved right 2. You move it right 2 and then stretch it out. No, times 3, so it shrinks it in by a third. So it's in here something like this. So the domain was from 2/3 and up. So the range of the inverse would be from greater than or equal to 2/3. What the domain of H was, that's the range, 2/3 to infinity. The domain is what you got out. Well, out of this we only get positive numbers, so that's from 0 to infinity. And you can graph this. You can see that you can put in, this it says you can put in anything, but since it's H inverse, we have to be careful here. 0 to infinity, yeah, we can put anything from 0 to infinity for this, and because it's got to be the inverse, so it's got to look like that. So from 0 to infinity we put in, and we get out from 2/3 to infinity. All right. Parent function looks like an x squared, y equals x squared, so I'm going to draw that. And we did 0, 1, 1, 2, 1, 2, 3, 4. Units on my graph. And working with the inside first, it says move it plus 1 to the right 1. So now it's there, 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 and 1, 2, 3, 4. 1, 2, 3, 4. Right 1. Then on the outside, we do them in order. Multiplication comes first. We have a minus, so I'll do a vertical flip. So I'm going to move the axis up. So now it's there, 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 and 1, 2, 3, 4. And that's reflect over the x-axis. And then we got to go by a half, which would do a half on the outside actually does compress vertically. By 1/2. So now that one is there. Oh, I forgot my units. 1 and minus 3. And that's 1. And this is now going to be at 1 over. It's not going to be down 1, but it's going to be down a half. Half as far from the axis. And at 2 was down 4, so now it's only down 2. And then I would need one more to do plus 2. And since I don't have another one here, it would be plus 2. It would go from there to there. So I'll put it on here. Then say up 2. Okay. Two, 4 is on the graph. Where does it move it to? So 2, 4 goes to 3, 4, goes to 3, negative 4, goes to 3, negative 2, goes to 3, 0. Oop. Okay. Find the intercepts of the line of symmetry for this things and the vertex. Well, the vertex, since this is moved to the left, to the right 2 and up 8. So the line of symmetry is x equal 2. Let's just move over 2. So I got the line of symmetry. I got the vertex. Now the intercepts. So the x-intercepts are when I make y be 0. So I've got 0 equals 5 times x minus 2 squared plus 8. So I'll subtract 8. Divide by 5. X minus 2 squared equals negative 5/8. Then I would take the square root, but it's a negative, so no x-intercepts. Now, if this was positive, I would take the square root and say plus or minus, and then add the 2, and I have 2 plus or minus this. These are going to be imaginary because they're the square root of negative. So no real x-intercepts. There are imaginary ones. And what's the y-intercept? Well, it's not 8. You put 0 in for x, and you get 5 times 0 minus 2 squared plus 8. Minus 2 squared is 4 times 5 is 20 plus 8. 28, but that's not the intercept. The intercept's a point, so I have to go, I put in 0 for the x and got 28. So there's the y-intercept. The line of symmetry, the vertex, and no x-intercepts. This one, let's write it in order. Minus x squared plus 6x plus 7. And since it's upside down, it's going to have a maximum. And find that value, so it would happen at minus b over 2a. Happens at x equals 3, but we have to find the maximum. So we put 3 in here, and we get minus 3 squared plus 6 times 3 plus 7. So that's negative 9 plus 18, which is 9 plus 7, 16 is the maximum value. Line of symmetry. That happens at minus b over 2a, which is x equal 3. That's a line, so it's got to be an equation. Determine the vertex. Well, if we put it's at 3 and at the highest place it gets to, 16. Solve this for when this is greater than or equal to 0. Well, let's just kind of quickly think about this. X minus, is there any holes? No holes. There's a vertical asymptote at -5. Single one, so it goes opposite on either side. There's a vertical axis, that's 0 at 2. Single, so they go opposite on either side of that. And at -1, single factor, so it's opposite. X-intercept at -2 at 3, 1, 2, 3, and at 0. See, the degree of the numerator is x to the third. The denominator is x to the third. This would be x to the third over -x to the third. So they're equal to degrees, so it's the ratio of the leading coefficients, which would be 1 and -1. So it's -1 is the horizontal asymptote. So out here, it's getting closer to this line. So that means it must go like that. And if it does that and it goes opposite, it must go from here through there and like that. And since it's opposite, it must go through here and through there and like that. And since it's opposite, it must go from here like that. So when is this greater than 0? From -5 to -3. And it can be equal to 0, doesn't exist at -5. And then from -1 to 0, we can include the 0, and from 2 to 3, not including the 2 up to 3. You can also just find all the points of interest, which would be this point, this point, this point, this point, this point, this point. Check in this area, just plug a number smaller than -5, like -6, and see if it's positive or negative. It turns out that'll be negative. Let's do that one. Let's put -6. This would be negative. This would be negative. This would be negative. -6 would make that negative. -6 would make that be positive. -6 would be negative. So I got negative times negative times negative, which is negative over negative times positive times negative is positive. So I have negative divided by positive, which is a negative answer. We don't want negatives. If you check between -5 and -2, you'll see that it's positive. If you check between -2 and -1, you'll find out it's negative. Between -1 and 0, you'll find out it's positive. And between 0 and 2, you'll find out it's negative. So we don't want that section. And then from 2 to 3, we find out it's positive. And after 3, it's negative. Determine the roots, real and imaginary. So we have one where we type it into the calculator to see what they are. Mode, I want to be function, y equals, we want to put in x to the 5th plus 5x to the 3rd minus 7x squared plus 2x. I see an x in all of them, so one of the zeros is going to be at 0. Let's go zoom on. Zoom 6. I don't know why the grid's on here. On that. Second format. Grid off. Zoom 4. I'm going to go. There we go. Let's see. As 0, oh, everything's there. I didn't really close in there. And 0 is one of them. And then it goes through in another place and a couple more places in there. And what are they? So zoom in, enter, enter. Let's see if we can get any of those. So let's go second, calculate the 0 that's between 0.1 and 0.6. 0.5, and it says 0.409. Oh, ugly, ugly, ugly. So this is not going to have very nice ones. So there's going to be 2 real roots, 3 real roots, 0, that one, and that one, and they're not nice numbers. That's in X. Second quit. X, see that's what's in X. Math, enter, enter. See if that's a nice fraction. It is not. All right, so this is a nasty example here. So we've got synthetic division with an ugly decimal. 1x, let's take out an x, because we know that's 1. So 1x to the 4th, 5x to the, 0. If I take out an x, I get x to the 4th minus 5x squared minus 7x plus 2. So I'm going to have 1x to the 4th, 0x to the 3rd, minus 5x squared, minus 7x plus 2. Since I have such an ugly number, I have to do this with this ugly number. 0.4095. It's some kind of square root, and I don't know what it is. So I'm going to use that. I'm going to use it in the calculator. So I'm going to store that in X just to make this easier for me. So 1 plus 0 is 1. 1 times X is this number, 0.4095. Add it to 0, so I'm going to have 0.4095. And I'm going to take it times that, so I'm going to have this number squared. And so I'm going to have 0.1677, and I have to subtract 5, and I get minus 4.8322. Then I have to take it times that, what x was, times the original x that I stored it in, so that's minus 1.979, and then I gotta go minus 7 more, minus 7 from that, and I get minus 8.978 times x, and I did something wrong here. Maybe I typed it in wrong. Let's check it. 5x to the 5th plus 5x to the 3rd minus 7x squared plus 2x. Subtract, take out an x, so it's x to the 4th minus 5, plus 5x. Okay. So I should have added that. So this would not have been this number. This would have been 5.1677. So second quit. So I've got, this was the x squared plus 5, that's this number, times that number I stored in x. So here I should put 2.116 and minus 7, and that should be 4.8836, and then times x, and I get minus 2, which is 0. Blah. Sorry for that. I didn't mean to make it this messy. And then we have to put in the other one into this stuff. So the other one, second to calculate, the 0, that's between there and 1, and it's about 0.7, and it says no, 0.7968. 0.7968. So I'm going to store that into x. Oh, no, I didn't want to do it here. So is x right? Yes. Store in x. That is an x. Okay, but I'm going to keep it in x. Okay, so 1 plus 0 is 1. Times this would be 0.7968. I have to add a 2 plus 0.4095. Now this is approximate, so we're not going to get exactly 0 probably. And I get 1.2063, and I got to take it times that, times x, and I get 0.9612. I got to add it to that, plus 5.1677, and I get 6.1289. I got to take it times the x, and I get 4, oh, and this was minus, and so I get 4.8836, which is 0. And I'm left with this quadratic. Ugh, ugh, ugh. And so I'd have to put that in the quadratic formula. I will not give you this uglier one. And this quadratic will be imaginary, it looks like. So if I go to the quadratic formula, program quadratic formula, and type in for my A, 1, B, 1.2063, and my C, 6.1289, I get imaginary ones. So my zeros are 0, this, minus 6, 0.6, plus 2.4i, and minus 0.6, minus 2.4i. So there's the 5 zeros. So I determined the roots, real and imaginary. Hopefully I won't make anything that ugly on the test. Determine the intervals where the function is increasing. So let's go back to the graph. Looks like it increases all the way to there, so we've got to find that max. Second, calculate the maximum between 0 and 0.5, and it's about there. and it says it increases from negative infinity up till 0.017. 177. We don't include it. And then the next time it increases is from that minimum. So second, calculate the minimum between 0.5 and 1 and about 0.7. It says nope, it's at 0.63. 0.638 to infinity. All this time it's increasing. Okay. Ugly. Sorry to give you that one. Hopefully this one's not as bad. Now we're determine the vertical asymptotes. So first of all, we need to factor this. There's an x in the numerator, so this would be x times x squared minus x minus 6 over an x in that, and that would be x minus 4. And this should factor, so we get x times x and x, and here we have to get a minus, so we might do minus 3 and plus 2. That makes minus 6. Minus 3x plus 2x is minus x, so that's that, and this is x and x minus 4. So vertical asymptotes, since that's a whole, the only vertical asymptote is that x equal 4, and since it's a degree 1, they would go in the opposite directions at it. Didn't ask for that, but it's helpful when you're trying to figure out what's going on. Horizontal or slant asymptotes, the degree of the numerator is 3, the denominator is 2, so you have to do long division. We can throw that part out, and so we just got to divide x minus 4 into what this was, which was x squared minus x minus 6. X in there is x squared minus 4x. Draw the line, change the signs, add them, and we get 3x minus 6. X into 3x is plus 3. So there's the oblique asymptote. Slant or oblique is x plus 3. Any holes? Yes, there's one at 0 in the x. And we plug it into the reduced form to find the y. So that'd be minus 3 times plus 2 minus 6 over 0 minus 4 is negative 4. So that's 6/4 or 3/2. 1.5. Intercepts. If I put in 0 for x, I get 3/2. And if I put in, if I try to make this equal to 0, we've already done the 0 there, so it'd be at, when x is 3, we'd get 0. And when x is minus 2, we'd get 0 from these two. All right, this says, and there's missing a parenthesis there, it says put 1 into f. So 1 minus 1 is 0, e to the 0 is 1, 2 times 1 is 2. So we're going to have to do g of 2, and so 2 minus 2 is 0. This is composite. It's an open circle in there. You can see a little bit of daylight in here. So we've got to put x into f. X into f is just that. So we got to find g of 2e to the x minus 1. And so we got to put this in for the x in g. So we're going to have 2e e to the x minus 1 in place of the x minus 2. This says g, a composite h of x, and that's an open circle, a little bit of daylight in there, so we got to put x into h. Well, the only x's we can put in are some specific ones, so we're going to just do those. So we're only going to have 4 answers, so we might as well just list them. So if I put in 1, it changes to a minus 1 in h, and so I got to put minus 1 into g, so minus 1 minus 2 is negative 3. If I put in 2, I get 1. 1 minus 2 is negative 1. If I put in 4, start with 4, it changes to a 3. 3 minus 2 is 1. And if I put in minus 1 changes to a 4, and 4 minus 2 is 2. Graph f of x. Exponential, so I'm going to start it down a little bit. If I put in 0, I get e to the minus 1. E to the minus 1 is 1 over e, so I get 2 over e, which is approximately 2 over 2.7, which is a little bit smaller than 1. So if I put in 0, I get a little bit smaller than 1. If I put in 1, 1 minus 1 is 0. E to the 0 is 1 times 2 is 2. If I put in 2, 2 minus 1 is 1. E to the 1 is e. Times 2 is 5.4. 1, 2, 3, 4, 5.4. So it's doing this. And it's going to get smaller and smaller and approach 0. And you can just type it in your calculator and it will show you that too. Now it says, I hope I wasn't off too much there. Okay. F inverse of x. So I replace the f of x with a y equals 2e to the x minus 1. Swap the y and x, so I get x equals 2e to the y minus 1. Divide by 2. Now I got to solve for the power, so I'm going to write this as a log, and the base is e, so it's going to be ln. To what power do I take e to get this? I take it to the y minus 1 to get x over 2. E to this power equals that. And then to finish solving for y, I add 1 to both sides, so I get ln of x over 2 plus 1 equals y, and then I write that with as the inverse. F inverse of x is ln of x over 2 plus 1. Evaluate the following to exact values. ln of e to something, they cancel out, and this is just 4.5 times 2. Ten to the log base 10, they cancel out, and I just get square root of 5. 8 is 2 to the third, so I get 2 to the third to the 3x plus 1 equals 2 to the 2x. Since they have the same base, the power is going to be the same, and I have to multiply the power, so I get 9x plus 3 equals 2x. Subtract 9x, and I get 3 equals negative 7x. Divide by negative 7, and I get x equals 3 over negative 7. This says, to what power do I take this to get this? This to the negative 4. So I got the square root of 3 to the negative 4 is x. If I rewrite it as a power equation. The square root is a half, so I got 3 to the 1/2 to the negative 4 equals x. And when I got a power to a power, I multiply. So negative 4 times 1/2 is negative 2. So this is 3 to the negative 2. The negative makes it 1/3, and squared makes it 1/9. Most people are taking and adding the log x to both sides, so we get the log of 7x minus 12 plus the log of x equals 2. To get this to be a single log, when you're adding, you multiply the arguments, so we get log base 10 of x times 7x minus 12 equals 2. So then I can write this as a power equation, 10 to the 2, which is 100. 10 squared equals 7x squared minus 12x. Subtract 100 from both sides. Now I have a quadratic that's equal to 0. And I might be able to factor it. And let's see, that would be 7x, and see, I want to get 12, so I might do 7 times 2, no, 428, 428, and 4 times 25. 28 and 25 would be 3. Nope. Let's put, if we did 5 times 7 is 35, and 20 would not be there. Not easy one to factor. Let's just go to the calculator, program, quad formula, enter, and we have A as 7, B as negative 12, and C as negative 100. And it doesn't factor two nice numbers. Did I make a mistake here? Let's check, because I usually try to make these be nice numbers. So 7x minus 12, and then plus log of x. X times this is this. 7x squared minus 12x equals 10 squared, which is 100. Subtract 100. I guess this is what we get. So it looks like x is supposed to be, according to the quadratic formula, either 4.732 or negative 3.018. Log of x, we can't put in the negative, and does 4 works in there. 7 times 4 would be 28 minus 12. That would be okay. So looks like that's the only answer. And it's not a pretty number. This one, we have unequal bases. But since it's not to a power, we don't have to set these to same bases. We can write this as a log equation. So this would be log base 2 of 3 is supposed to be x plus 1. 2 to the x plus 1 equals 3. So to solve that, I just calculate this, which is, and subtract 1. So I'd have log of 3 divided by log of 2, that's what this is, minus 1 is x, so log 3 divided by log 2 minus 1, minus 1, and I get x to be 0.5849, blah, 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 blah. This would be the exact answer. And the last page. Sorry about that phone ringing a little bit ago. Last page. So bacteria is growing. Number that there is after a while is the starting number, e to the kt. So amount after some time is equal to the starting amount. This is what I used in class, but it could be with an n or p or q or whatever. Kt. And it says n is the number of bacteria in the culture, and t is the time expressed. 500 bacteria initially. And 800 after 1 hour. So now we got to solve for k. So we divide by the 500. And so that's 1.6, I believe. And equals e to the 1k. So to solve this, I will write this as ln of 1.6 equals k. E to the k is 1.6. So ln of 1.6 is 0.47000 something. Okay. Determine when the number of hours one will be 40,000. So we would have 40,000, assuming we're still starting with the 500, e to the 0.47 t. So we'll divide by the 500. So that's 80 equals e to the 0.47 t. T is in hours. So write this as a log. So the natural log of 80 equals 0.47 t. E to the 0.47 t equals 80. So t is going to be log of 80, natural log of 80 divided by 0.47, which is 9.32 hours. And finally, the last problem. The amount of medicine remaining in the body after t hours is this formula. So k is going to be negative because it's decreasing. And k for this medication is negative. If the initial amount is 350, so we put that in for A0, so we got 350 e to the negative 0.085 t equals the amount left, and it down to be 10 milligrams. So we divide the 350 out. And the zeros cancel. And so we write this as a log. So ln of 1 over 35 equals negative 0.085 t. So we divide it by negative 0.085. And we get the time to be ln of 1 divided by 35 divided by negative 0.085, and we get 41.8, and t is in hours.